So, more about parallelograms today. Today, there's 5 what we call sufficient conditions to prove that what we have in front of us is a parallelogram. So let's just talk about what we know about a parallelogram so far. Like, what would be the most obvious way you'd know that, like, one of those guys is a parallelogram? It's got 2 sets of parallel sides, right? Isn't that the... So out of these 5 ways, I can tell you, we know 4 of them already. We already know 4 of them. The first way is if you got 2 pairs of parallel sides. That is by far the most obvious way to know that that's a parallelogram, and then you should mark it with 2 sets of parallel sides. So meow, 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 meow. That's what the old picture would look like. But without having that, what's another way that we could know that something's a parallelogram? What else do we know? Opposite angles could be equal, right? Or congruent, however we want to say it. Right there, opposite angles congruent. How do you mark that? How do you mark that over here? Arc marks, right? So if I call this A, B, C, and D, which you don't need to do, but if I put a single arc mark in angle A, where does the single arc mark go now? All right, because those are opposite angles. Then what about these? Do they need to be the same? So it's not just one set of opposite angles congruent, correct? It's how many sets. So we don't really write that down, but when we say opposite angles congruent, we're talking about both sets of opposite angles congruent. You with me on that? And they're different. Cool in the hood? What's another way besides opposite angles being congruent to each other? Opposite sides being congruent to each other. Right? Tick-a-bow, tick-a-bow, tick-a-tick, tick-a-tick. If we had that, that's enough right there to know that that's got to be a parallelogram. Like, these are ways we're proving that something is a parallelogram. So far, if it had 2 parallel sides, duh, that's the definition. But if a quadrilateral had opposite angles congruent, it's got to be a parallelogram. That's what we're saying here. If a quadrilateral had opposite sides congruent, it's got to be a parallelogram. Cool. What else do we know? Consecutive angles are supplementary, correct? Well, that kind of gets in here, you know, sort of kind of in here. You know, it's kind of like those two go together. If you have opposite angles congruent to each other and consecutive angles are supplementary, right? What else do we know? The diagonals bisect each other. That's what we know. Diagonals bisect each other. And any two consecutive angles are supplementary. That was that other guy, right? You know, because that kind of flows with this one, sort of, kind of, maybe, if you want to. Because if you have these 2 consecutive angles supplementary and these 2 consecutive angles supplementary and these 2 and these 2, it would turn out that your opposite angles would be the same, right? So it flows together. Cool. Let's put that in our picture. Draw me the diagonals bisecting each other. Probably a good idea to use a straight edge. So, like, does the red one cut the blue one into 2 equal pieces? Yeah. And then the blue one cuts the red one into 2 equal pieces. Should I put single tick marks again? Why can't I put single tick marks again? They're not the same length. Those diagonals are not the same length, but they do cut each other into 2 equal pieces. Cool? So that's it, right? Those are the 4 that we know. The 5th way is new to us, so we'll just discuss it. Here's the 5th way. If you have one pair of sides that are both parallel and congruent to each other, what's the magic word? Both. One pair of sides, both parallel and congruent, is the 5th way. If you have one pair of sides, both parallel and congruent. The magic word is both. So, like, let me draw you some stuff, see if you feel that it satisfies or does not satisfy. Obviously, you have to have what? A set of what? Parallel sides, right? So I got to have that. And you got to have a set of congruent sides. So what do you think about this? Don't draw it. Just think. What do you think about that? Is that one pair of sides that are both parallel and congruent to each other? No, because the parallel sides are these guys, this green set. The congruent sides are the black set. That's not the same thing, right? So it doesn't work that way. What if I did this? Does that work? It's like the same picture over again. What if I did this? Yes. What if I did this? Yes. So let's see why that works. If you have one pair of sides where the tick marks and the arrows are on the same set of sides, that has to be a parallelogram. Why, oh why, oh why, oh why would that have to be a parallelogram? Well, let's do some pretending. Let's pretend that I had that in the picture, which is just one of the diagonals. Cool? I want to prove that that's a parallelogram, given this information. I have a set of congruent sides, right? What else did they give me in this problem? Parallel lines. Can we get something from parallel lines? What can I get? Alternate interior angles would be congruent. So if I put an arc mark here and here, does that work? No. That doesn't work because those arc marks don't touch the parallel sides. If I put an arc mark here and here, does that work? Cool. I'm trying to prove this is a parallelogram. So far I have just done that. Parallel lines imply that those alternate interior angles congruent. Cool. What would you do next? Trying to prove that this is a parallelogram. Say that again. Okay, like that. Why? It's a shared side, so reflexive property. This segment is congruent to itself by the reflexive property. Everyone comfortable with that? Whoop-de-doo. Oh, there are two triangles in this picture? Tell me about those two triangles. They're congruent by which method? Side angle side. Awesome! That those two triangles are congruent. How will that help us if those two triangles are congruent? Then these two other sides you're saying should be congruent to each other? Well, why? Because they are corresponding parts of congruent figures, so they should be congruent to each other, right? So how does that make that a parallelogram? Opposite what? Opposite sides are congruent to each other. Or, if you didn't want to do that, could you have done this? You proved the two triangles congruent by side angle side. Could you have said that this angle, is congruent to that angle? Because those are corresponding parts of congruent figures which are congruent. And then if these two angles are congruent, shouldn't these two sides be parallel to each other? Because alternate interior angles congruent implies parallel lines. And then is that a parallelogram? Yes or no? That's got two pairs of parallel sides, right? So it's all cool in a neighborhood. They want to know on these problems, do you have enough information to prove that this is a parallelogram? So you should go back to your picture and mark that. Sorry if you hadn't done that already. That it should look like this. One pair of sides, both parallel and congruent to each other. Looks like so. Here they want to know, do you have enough information to prove that that's a parallelogram? I hope you learned your lesson on the Chapter 5 test that numbers don't really help us. Markings do help us. Instead, in this first problem, you got some 12s the same? Mark them. Do you have some 8s the same? Question, is this a parallelogram? Yes or no? Yes. Reason? Opposite sides congruent. Pretty simple right there. Right? You get the name of the game here, what we're trying to do? Do we have enough info to prove it's a parallelogram? Number 2. What do we got? One pair of parallel sides. Is that a parallelogram? Nope. Do you see the 9s? Mark them. Now, I do have opposite sides equal. I do have one set of parallel lines. Is that a parallelogram? Sometimes it is, sometimes it isn't. What do you think? How come the answer is yes to this? Because it's on the same thing. They're both parallel and congruent, so yes. If we were doing a proof, what would you write for your justification over there? Would you write down definition of parallelogram? This is not the definition of parallelogram. What would you write? One pair of sides, both parallel and congruent. What we wrote up in those 5 guys up there are the justifications we will use in our proofs, right? Except for number 1, you won't write 2 pairs of parallel sides. What would you write instead on number 1? So let's go back and do that. Let's just kind of say that this is the definition of parallelogram right here. These are our justifications we would use in a proof, and the only one that's really the fanciest is number 1. It's the definition of a parallelogram. All good in the neighborhood? So let's try number 3 over here. Do we have enough information to prove that this is a parallelogram? I got some tick marks, right? Let's go through all 5 ways to see if they work. 2 pairs of parallel sides. Do I got it? Nope. Next one. What's the next one? Opposite angles congruent. Do I have that? Nope. What's the next one? Do I have opposite sides congruent? 1 set, but kind of how many do you need to have? You got to have both sets. Do we have both sets? Nope. So diagonals bisect each other. Do we have that? Does this green one bisect this red one right here? Yes or no? Yes, it does. Does the red one bisect the green one? So the diagonals do not bisect each other. You with me on that? I don't know if the green one got cut into 2 equal pieces. Do I have 1 pair of sides both parallel and congruent? All 5 ways failed. Is this a parallelogram? Nope. Try number 4 with PAL. This guy is most definitely a parallelogram. How come? Diagonals bisect each other. Next. Don't just say diagonals bisect. What's the cool words afterwards? Each other. That makes a big deal. Next one. What do you think? Do we have enough info to prove that that's a parallelogram? Looks like opposite angles being congruent. Aren't these opposite angles? Booyah, booyah. Correct? Is that enough? Why not? You got to have both sets. Well, wait a minute. Should this be 110 degrees right here? Like, are these supposed to be supplementary? Only if those lines are parallel to each other, right? And if they were parallel, wouldn't we already know it's a parallelogram? So what do you think? Yes or no? Do we have enough information to prove that this is a parallelogram? Nope. What about the next one? So mark them. Meow, 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 meow. Yes or no? Yes. How come? Opposite angles are congruent. If you have equal, I won't mark that wrong either. Sometimes I say equal, sometimes I say congruent. Let's play with the old numero 7, the siete, if you will. What are we thinking on 7? Yes or no? Well, I'm going to need some proof, because right now, those 5 ways, I don't have all that information. So where are we starting from? What's the most important thing you would start talking to me about when you explain? We do have right angle boxes. Yes, I'll give you that. We also have parallel lines, right? Which one do you think is more important in the situation? It depends on where you want to go with it, because you can use those right angle boxes to prove some other stuff, right? But parallel lines is probably pretty comfortable for us. How do they help us? What does that mean? Do we have 2 pairs of parallel sides, yes or no? No, there's just 1 right there. So how does that help us? Consecutive angles between parallel sides are supposed to be supplementary. Isn't that a property of a trapezoid right there and stuff we learned a few chapters ago? This is a trapezoid, right? And aren't these consecutive angles right here between, like if I call this angle 1 and this angle 2, aren't they consecutive angles between those parallel sides? They got to be supplementary. So if this is 90, how much does that got to be? And same thing here, right? So what do you think? Is this a parallelogram? Yes or no? Yes. Why? Because the opposite angles are congruent. Anybody got a different way to prove that? It's really a rectangle, correct? You know, but anybody got a different way to prove that? These 2 angles right here? Yeah. Those 2 angles, are they right in a row? Yes or no? So those are consecutive angles that are supplementary. What does that imply that we have? So shouldn't this be parallel to this right there, which would mean now you got two pairs of parallel sides, and that's still a parallelogram, right? There's more than one way to go around it. 8! That's the next one, Jace. Can we put any more markings in this picture based on what is given to us? What do you think? What do we want to put then? People said yes. What do you want to say? This, like a shared side between the two triangles? Okay, I'm cool with that. Can I prove these two triangles congruent right now? No, this is ASS. Doesn't work that way, so it doesn't work. But it's true. Segment AC is congruent to itself, so I'm cool with you marking it. Can you put any other markings in the picture? Can you put any other markings in the picture? We got these angles congruent to each other, correct? What does that mean? What kind of angles are those? Aren't they alternate interior angles? So I'll get some parallel lines out of that. Which segments should be parallel to each other? Correct. The ones that the arc marks touch. Shouldn't those be parallel because alternate interior angles congruent implies parallel lines? Cool. Is that a parallelogram? Do we have one pair of sides, both parallel and congruent? I got parallel lines, right? I got congruent sides. But why doesn't that match the old one pair of sides, both parallel and congruent? Not on the same things. Not both, right? The magic word is both. Can we do any more proving of stuff? Like what? Angle BCA, slow down. Angle BCA, this angle right here. This is a suggestion. They're saying that this should be to this. Why? ECA. Say that again. This guy? Okay. That these have to be the same? Why though? Just because these are the same, those have to be the same? Ooh, symmetry lines, symmetry lines, symmetry lines. First of all, we got to know what shape this is to know if it has any symmetry lines. Is this a symmetry line for this thing? We don't even know what shape it is. Even if it was a parallelogram, does the parallelogram have any symmetry lines? So at least that's a good idea, right? Here's the only way you'd know that these angles were the same, is if these sides right here were parallel to each other. Are those sides parallel to each other? We don't know that yet. We're trying to prove that, kind of, sort of. So good thoughts. We got to back it up, though. Okay, how about we just erase? No dice. Can we get a smaller eraser, please? Thank you. Anything else we could do? We prove the triangles congruent at all? Anything like that? Yep. Is there right angles? Someone asked. What do you think? Is there right angles? It looks like it. It looks like it. Is that good enough? If you were doing a T-chart proof, say, these are right angles. Justification, they look like it. Yeah. What? Say that again. Like, name them for me. CBA, this one? And this one? Are those alternate interior angles? Because they're not touching like the same segment and on alternate sides of the transversal. Those are opposite angles in this particular quadrilateral. And do we know if they have to be the same? I don't know that. Do we have enough information to prove this is a parallelogram? No. One more. See these single arc marks right here? Do they both touch this green segment? So they're on like alternate sides of that green segment, correct? And each one of them is touching this guy and that guy separately. Tell me what has to happen about those two red guys. Because aren't these alternate interior angles because they're between them? So that would imply that those are parallel lines. What about the double arc marks? Are they also touching the green segment? And they are touching these sides also? Aren't they on alternate sides of that green segment in between those two red ones? What has to happen with those? Do we have enough information to prove this is a parallelogram? How come? Right, two pairs of parallel sides, aka the definition of a parallelogram. To the back side. What value of x and y make the quadrilateral a parallelogram? What do we got in 13? What do we got? What do we got? Like, no, what do we have? What did they give us? What do we got? Angles, right? Not sides, angles, correct? We're on 13. So, what do we know about angles? If that's supposed to be a parallelogram, what should happen with the angles? The opposite angles should be equal. So, where do you want to start? 3y should equal 42. Divide by shwi. Ah, 14, right? So what's that mean right there? It says what value of x and y make the quadrilateral parallelogram? If y was 14, we'd be in business, right? But it doesn't have to be. But if y was 14, it still wouldn't make it a parallelogram because just this would be 42 and that would be 42, right? Wouldn't we need this to be something also? So we need to figure out what x is. What can we do with this guy? Yeah, I like to say these two put together should equal how much? 180. What you said wasn't wrong, you know. It's like this. 8x minus 6 plus 42 should equal 180, right? And you said subtract the 42 from 180, which you could do. But I'm going to just combine like terms right here. Solve for x. Kind of shows that since these are consecutive angles, they have to be supplementary. So that's 8x plus 36 equals 180, right? And 8x equals 4, and that'd be 17, 144, right? And then divide by the 8, that would be a 1 with 64, 18. Yeah? So if x was 18 and y was 14, then this would have to be a parallelogram. You with me on that? Because that would force the opposite angles to be equal to each other. And people are like, well, what about this one right here? Well, because if this is 42 and this is 138 and this is 42 and all four angles add up to 360, this one has to be 148, which would make your opposite angles congruent to each other. Next. What did they give us? Sides? What do we know? If this is supposed to be a parallelogram, opposite sides should be equal. So help me out. Give me an equation. Let me put this in a new window here because I would like to put this in a new window. What do you want to say? 42 equals 4x plus y. I'm going to write it like this instead. 4x plus y equals 42. Is everyone cool with that? Should that happen? Yes or no? Let's just time out. Should these two be equal if it's a parallelogram? Yes or no? Yes. Is this equation good for you? It's correct, but it sucks. Why does it suck? It's got two variables. So what do you think? Well, to do elimination, I'd probably need a system of equations to solve this. And with this green equation, I can't do anything with it, right? If I want to solve for x, won't there be a y in the answer? If I want to solve for y, won't there be an x in the answer? So since you have more than one variable in this, it would be awesome if you could get another equation with those same two variables from this situation. Can we do that? What would you say? 3x minus 2y, look where I'm writing it, equals 26. Are we all down with that also? And notice how I wrote that. I wrote that red one directly underneath that green one with x's on top of x's, y's on top of y's, equal signs on top of equal signs, and constants on top of constants. We want to solve this system of equations since they're both the same variables. You wanted to do elimination? I agree with that. What do you want to cancel, x's or y's? Cool. If this is a negative 2y, and this is a 1y, they won't cancel. So what do you want to do to that green one up there? Cool. And then I like to cross this guy out once I've multiplied him by 2. And let's add these puppies up. 8x and 3x, how much? 11x. Don't the y's cancel? And 26 plus 84, that would be a 0. And carry the 1, 110, right? So what does x equal? 10? We cool with that? Are we done? We found x. What do we need to find now? We need to find a y. So I'll take it into any of these equations. It doesn't really matter. I'll go back into this top equation to be quite honest with you. Did you get y equals 2? There's an example of when a system pays off. You've solved systems for like a year now, and it's like, what are we doing this for? Why do we solve? What do you just need a system for? This is very helpful when you've got a couple of equations with different variables. Should I write this answer as an ordered pair? Should I write it 10, 2 in parentheses? No, it's not where these intersected on the graph or anything like that. You know, we don't need an ordered pair. But what I do want is you to at least box both answers so I can see both answers. I don't want to search all over the place. If you did work, you know, some of it's way up here and some of it's way down here, put your two answers together so I can look in one spot and find them. You understand that? So I don't want to search left, right, up, down for your two answers. Next. Ooh. Let's do this one right. We got plenty of time here this hour. Let's do this one right. They want this to be a parallelogram. What do you think? Okay, somebody's picking on 3x. I'll pick on 3x. I'll put an arc mark right here. 3x. What do you think? The same as 7y minus 2? What? What? Why? Aren't those alternate interior angles? And we're trying to prove this is a parallelogram. So if these sides were parallel, shouldn't those be the same? Right? So let's do that. Let's say 3x should equal 7y minus 2. Stop and think. Will I need a system to solve this problem? Well, look at that equation. There's no probablys about it. Will I need a system or not? Yes or no? Because there's an x and a y in this problem, or in that equation, correct? So I need another equation with x's and y's in it. What else could I write? 9y equals 4x plus 1. Y'all cool with that? Aren't those another set of alternate interior angles that should be congruent? Now I got the ingredients for a system, but holy crap, what's not cool? It's not all lined up. I'm a fan of elimination, and I'm a fan of putting them in standard form. X first, y second, equals third, constant fourth. Do you like it that way also? So let's do that to the red one. Let's just kind of do this. Let's say you're going to come over here, and is the x first? Yes or no? 3x is good. Cool. What about this y? Is y next? Well, you see this? Does that say something with y's? Is y next? Yes or no? No, I need it to come next. How do I get this 7y to move over here? Don't I need to subtract them over? So over here, wouldn't I have 7y? Excuse me, minus 7y. Is everyone with me on what I did right there? This 3x is cool. It's on the left side of the equal sign, and we want it first. Don't we want it to look like this? ax plus by equals c, to where a, b, and c are just numbers. Don't you want the stuff with the x first, then plus some stuff with the y's, then the equal signs, then the constants? X first? Yes. Y second? No, there's an equal sign there. Don't you need this to come over here, and you subtract them over? Then, equal signs there. Is the constant already on the right side of the equal sign? Yep, so the minus 2 is cool. You could think of it like this. You need all your variables on the left and all your constants on the right. Was he on the left side of the equal sign? Yes or no? He was good. Was he on the left side of the equal sign? So he had to move. Was he on the right side? Since that's a constant, was he on the right side of the equal sign? Yeah. Try that to the green one below. See if you can get that in standard form. Put it right below this guy. X is first, y second, constants last. I need the x's first. Here's the x's. They're supposed to be on the left side of the equal sign. Is that happening? Nope. So I need to move them over there. And how do you move them over there? So minus 4x. Correct? Done with them. How about the y's? Are they on the correct side of the equal sign already? The y's, here's the left side. Aren't they already over there? So is it a positive 9y or a negative 9y? Done with them. How about the constants? Are they on the correct side of the equal sign already? Isn't it already on the right side? So equals 1. With me on that? Nice. Let's solve this system. What do you want to do? What do you want to cancel? X's or y's? X's would probably be a little easier. What do we need them both to be? What's the least common multiple between a 3 and a 4? So turn one of them into a positive 12, turn the other one into a negative 12. Boom. So bye-bye. How many y's are you left with? Negative y equals negative 5. If negative y equals negative 5, what does y equal? Now, are we done? We need to find x, right? We need to find x. So we can substitute into any of these equations that we really want to. And I'm looking around. I know a y value. I'll probably go back into this one, to be quite honest with you. It doesn't matter. You got 1, 2, 3, 4, 5, 6 different equations to choose from. It doesn't matter where you substitute back into. So 3x equals 35 minus 2. 3x equals 33. X equals 11. And then I'm going to write them next to each other. X equals 11. Y equals 5. Put a box. Is everyone cool with how I substituted that 5 back in? You got 5 different equations. It doesn't matter which one you do. I just chose one of them. Cool? Next one, typos galore. If you'd fix those typos in there, then we'll do this proof together. So pause the video, fix the typo. So we got all these typos, and we'll read the given, write the given, mark the given, because none of this is dirty. Angle ABD. Angle CDB, and this is congruent to that, because they told me so. Trying to prove that parallelogram. Cool. So then we'll go back to the vote of proof 2 triangles congruent. We could do that, right? You said we have alternate interior angles. We could use those maybe. Flip to the front side of your paper. How many ways do you have to prove that something is a parallelogram? 5. There's lots of ways we could get this done. What would you like to do? We can use those angles that they gave us, right? Usually if they give us something, we should use it, right? If we use these alternate interior angles that are congruent, what do we get from those? Parallel lines. So which sides would be parallel, though? That's my question. Segment AB and segment DC. Question. Do we want to go down that path, or do we want to prove the 2 triangles congruent? Would it be very convenient to get these sides that are already congruent to each other parallel to each other also? So let's do that. Segment AB. How do you write that they're parallel to each other? Slash, slash. Now you get your justification for step 2 and see if you do it right. I gave you 2 options right there. Parallel lines implies alternate interior angles congruent, or alternate interior angles congruent implies parallel lines. We could call it red or green. Which one is correct in this case? Why is it the green one? We were given alternate interior angles congruent, and aren't we proving that those segments are parallel to each other? So, goodbye. This one. Sweet. Should we mark that in the picture? Do it. What do you want to do now? Do we have enough information to prove this is a parallelogram? Sweet. A, B, C, D is parallelogram. How's come? One pair of sides. What's the magic word? Both. Parallel and congruent to each other. D-O-N-E. Done. That was 3 steps. What if we wanted to prove the 2 triangles congruent? Could we do that? What would you do next? Not equal to itself. What is it called? Congruent to itself. Why? Are the 2 triangles congruent now? So you'd say triangle meow 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 is congruent to triangle meow meow meow. How come? Side, angle, side, congruence theorem. Then how would you get that to be a parallelogram? What would be the next easiest step to do? Boom, 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 congruent to that, right? So step 4, segment AD congruent to segment BC. Reason? Corresponding parts of congruent figures are congruent. Step 5, ABCD is a parallelogram. Reason? Opposite sides are congruent. 5 steps, right? Which way's better? It's up to you, man. You know, whatever you want to roll with. But more than one way to get there. And we could have done many things. Once you prove the 2 triangles, you can do all sorts of stuff. So.